Okay, a few announcements. For your lab test 1 on Friday, there will be a review session, optional. If you find it necessary, just attend. It will be tomorrow, Thursday, from 10 a.m. for 1 hour. It's in Ross Building, South Tower. You can check the course Moodle for more information, okay, for this place. Take the elevator, don't take the stairs. You might get lost very easily in the Ross Building. I lost this morning, actually. And for lab test 1, I also emailed everybody yesterday about seating plan. Please read the seating plan. Tia will help you during the lab test, tell you where to sit, but make sure you're familiar with that. And for your lab number 3, I want to emphasize something. I know you're very occupied by your lab test 1, but take my advice as follows. For lab number 3, lab number 4, and also your projects, you're going to use a framework called ETF, IFO testing framework. And I would suggest, while you're still being very occupied, very concerned about lab test 1, do the following. If you go to the lectures page, so there is a tutorial series about IFO testing framework. Just follow the tutorial to see what a framework is for the simple example. That will save you tons of time when you actually do the labs. Okay? That would be my advice for you. All right. And there's certain thing about regression testing. I will either record some short tutorial video to help you on that, or maybe we'll just hold some extra session during the reading week. Again, it'll be optional. Okay? I'll get in touch with you about this. Okay. All right. If you got any questions related to the lab test, save it for tomorrow. Okay, I'll be there to answer any of your questions. Okay. All right. So now let's continue with our lecture from Monday. So the goal for today, I would like to finish about expended class versus reference class. And then we'll talk about a simple design pattern, the Singleton pattern. And we try to contrast about the design rationale versus how you would do it in Java, just to have some comparison for your information. Okay. So this is how we introduce about expended class. Basically, for your particular application over here, for each workstation, you got workstation 1, 2, and 3. There are certain parts like a keyboard and CPU. They are simply not shared, in which case they are more like a composition, as you learned from 2030. Whenever you don't have any sharing between certain objects, you should really try to use a copy constructor to implement it properly. On the other hand, there are certain parts, for example, the network. You can see all the network objects are pointing to the same network over here. Okay, so that's more about sharing, that's more about aggregation. Okay, how do you kind of translate this kind of design idea in IFO? They do have support for composition for you. You don't have to implement the copy constructor yourself. It's called expended class. And I will show you exactly how that works and give you some example. And then for aggregation, just a normal reference type. Okay, so it's not a lot of new things to learn here. Just learn about the keyword expended. Okay, so this is the two styles of using expended class. Okay, either you can say, for every class I have, I simply create them as non-expended. Whenever you have non-expended, simply means it simply is a reference. Whenever you create an instance of the class, you just get an address. On the other hand, over here, if you got expended over here, it will have some special behavior at the runtime, which we'll see. Okay? And how can you declare attributes of expended type? Either you can say I refer to some non-expended class. For example, if you just see the keyboard alone, it's actually non-expended. And then I simply add a modifier expended before that. So that would make K expended, which means at the runtime, K is not going to be shared among the workstation. Okay? Another way to do it is you can say maybe when I declare the keyboard class over here, I will simply make the class itself expended always. So that means when you declare this particular variable over here, keyboard is just expended. And I mentioned very briefly, the approach above is actually more general for you. For example, consider the following scenario. What if the keyboard, it may be shared, or it may not be, depending on the scenario you're talking about. In that case, if you actually chose this particular version over here, by simply making the keyboard class just expanded, that means you're ruling out this particular option over here. That means keyboard can never be shared because at the class level, it said it's expanded. right? So it's not that flexible for the second approach. So I would say the first one is actually better. So now, if you follow, just a final remark, if you follow the final approach, what you would do is like this. The class for keyboard is simply just regular, okay? And now I do have to say, I say K1 and also K2, keyboard 1 and keyboard 2. So now I can say for keyboard number 1, it can be shared positive. I can say keyboard. On the other hand, maybe for keyboard number 2, I don't want it to be shared. In that case, I can say expended and then keyboard. Okay, just a little bit notes about which version you should really choose. I would say in general, choose the one above. It's just more flexible for you. Okay. Any question about expended, just up to now? We're going to see exactly how expended will work at the runtime. We'll just see that right away. So now I have some simple class over here to illustrate to you how the behavior will be like at the runtime for expended class. Okay? Before I do that, I would suggest I do the following. Okay? Just to make sure everybody is comfortable, first of all, about the reference type. For now, let me say the following, okay? If I simply say I don't have expended over here, so class B is simply just a regular class. When you instantiate B as an object, you can store its reference, like an address, okay? And then we have some command, which can we have some attribute here, I, integer, and then we can change I to any number we like. So there's no invariant for simplicity. Okay? So now we're not talking about expended. I just want to make sure you know, at least, without the expended, how things will work. Let's consider the following test case. And the source code is also available to you on the course website. You can also check it out. Let's say I declare EB1 and EB2 of type B. And we know that B is not expended to begin with. Okay? If I try to execute the first line, oh, by the way, I'm using a syntax over here. Hopefully you noticed that. So the check end expression here, whatever you put over here should be a Boolean expression. It's as if in JUnits, I said assert true. And then put something over here. Equivalence, okay, just a different syntax. Okay. I have a question for you. If I try to run this at a runtime, am I going to get an assertion success or failure or other?
Should there be a compiler?
Oh, Jordan, you think there will be a compilation error? Why?
Because don't you have to run that create on EB1?
That's good. Okay. Jordan actually pointed out exactly what's happening here. If you try the following line, actually, the compiler wouldn't even allow you to try because the code simply wouldn't compile. Because you can see this is the first line of your code. Whenever you're trying to call some attributes or feature, can be attribute, can be query, can be command, on some context objects. The context object for voice safety, right? That's something about that you did in lab 0. Voice safety. I, for compiler, try to be very conservative. Every time you try to use a dot notation to call some feature, you want to make sure the object is guaranteed to be something that's not void. However, in this case, is it the case that it's not void? Not quite, because this is your first mention of EB1. However, EB1 was never created, so EB1 will just be void, so you cannot even execute the code. Something to note about reference type. And be careful in your lab test 1, because anytime you want to create any local variable, make sure you initialize them first before you try to use it. Okay? It's a very common mistake. Okay, let's say I try that. I'll simply say, before the do over here, I will simply say creates, maybe EB1.make, and also creates EB2.make. Okay? Let's say I do that, so now it will compile. Let's say the make will simply initialize the value to be 0. Okay? So now we got EB1. It's pointing to some B objects where the I value is simply initially 0. Okay? I'm just going to keep track for you. EB2 is also pointing to another object over here of type B, and then I value is simply 0. Okay? Let's start from here. First of all, if I say the second line, check, is it going to pass or fail? I heard pass. If you say pass, that means you believe EB1 equals EB2 is going to return true, right? But why is that? When you say equals sign over here, what exactly are you comparing? Are you comparing address or are you comparing contents? Address, right? So shouldn't that be false? Would you agree? Okay, good. I'm glad you agree with me. So in order to make this particular assertion pass, so we can move on, I'll simply say not equal to. Okay, that should be what I should have written. Okay, I'll just put it so we can continue. Okay, that's about this particular line. Let me just highlight it, so meaning that we have handled that already. Okay, you should say not equal to. The references are simply not equal. And then let's say the following. The next line, I try to say EB2 change I to 15. Okay, so EB2 is pointing to this object here, so change that to 15. That was easy. And then for this particular assertion here, would you agree it's going to pass? Okay, good. So 0 and 15, not a problem. Okay, so that one we're happy about. Okay, that's also handled. And now, given that the I value in both objects are simply different, if I say EB1 not equal to EB2, true or false? True. However, it is true not because their contents are different. It's because they still remain to be two objects. Okay, be careful. Okay. Let me just highlight it for you. Okay. So this should be true. And because they are different objects. Different objects. Let's now do something interesting. Of course, you did it a lot in the previous OOP courses. Let's just do it quickly as a review. Let's say for now, I'm going to go ahead and try to do this particular assignments. EB1 is assigned to EB2. We know pretty well it's going to copy the address that is stored in EB2 into EB1, right? So conceptually, you can think about EB1 is not going to point to this current object anymore. It is now going to point to wherever EB2 is pointing to. Is everybody okay with this particular assignment? So now we got the so-called aliasing, right? Aliasing is a very critical phenomenon, when you talk about OOP, aliasing, just as a review for you. Okay? So that means EB1 and EB2, they are pointing to the same objects. Okay? So now let's go to the next line. If I check to see EB1.I will be 15, agree? Because EB1 and EB2, they are now pointing to the same objects, and it's 15. Okay, so that assertion there is guaranteed to pass. So that's not a problem. Okay? And now if I say the next line, EB1.change I to 10. So that means I'm going to follow this particular EB1 pointer and go to this object here, and then change that to be 10. So let me do that. And then it's going to be 10. Okay, so after this, if I say this check, is it going to be correct or wrong? Wrong, right? Because now EB1.I and EB2.I, since they point to the same object, of course, they should be the same. So both should be just 10. Okay, I'll correct that. Okay, finally, if I say check EB1 not equal to EBI, true or false? False, because they are different objects, okay? This will be false because they now reference the same objects. The purpose of doing this is just to make sure you understand how reference types behave at the runtime. Okay, any confusion, any question? Okay. So now, the next slides, I'm going to make this class a little bit different. Rather than non-expanded class, I'll make it expanded and see the same assertion, are we going to pass or fail? Okay, that's the purpose. So now let's talk about expanded class. So everything stayed the same, everything, except that I just added this word in front of the class. That's the only change. Okay. Now we said before, for reference type EB1 and EB2, the first line wouldn't even compile if we did not initialize the objects, right? But now, in the case of expanded, I can tell you right away, line number 5 is actually fine. That's number one thing you should know about expanded type. Expanded types simply have no notion about address. They always exist. even before you explicitly initialize them. As soon as you declare some expanded type objects, they will be initialized at the runtime automatically. Okay, that's something to keep in mind. So now, line number 5 is definitely okay. And then it's simply just going to initialize 2 objects over here. Okay, and I'm going to draw it a little bit different. I don't really have arrow, which means there's no address. When you say EB1, you talk about that particular object, not really its address. Similarly, when you say EB2, you also talk about that particular object without its address. Okay, there's no address. Okay, no notion of address. And then EB1 and EB2 of type B, of course. And initially, it will just be I0 and I0. Okay, let's start with that. Jordan.
I know I'm jumping ahead a little bit, but what I'm wondering is this sort of like making C structures that aren't allocated, they're just in like the stack, and then you set one of the structs to
okay.
copies all the...
It's not really on the stack, it should still be on the heap, because we still talk about objects, so they're still global structure. So basically, as soon as you declare EB1 and EB2, you're creating objects on the heap. Yeah.
Okay.
Yeah. Because, yeah, let me just leave that here. Okay. All right, so now let's go further. If I say EB1 equals EB2, remember in the previous case, they are not equal because they are different objects. But what about now? That's kind of tricky now, right? Whenever you got equal sign, you have to worry about the context. Okay? So let me make it clear to you. So now, if you have things like this, if you got equal sign, right? You got some objects over here, object 1 and object 2. How the equal sign is going to be interpreted at the runtime depends on the context of the 2 objects. Okay? Case number 1. If object 1 and object 2, assuming that they are of the same type, of course. If object 1 and object 2 are reference. Oh, let me make it a little bit more clear for you. Okay. Let's say, let me make it more context here. Let's say object 1 and also object 2. They are simply of type A. Okay. A can be any class, can be bank, can be data access, can be anything. Okay. So now, the way to decide what's going to be executed for equal sign is if A is not expended. Then you're going to compare the address. Okay, that one's just what you know before. On the other hand, if A is expended, you will compare contents. In that case, it will be as if you say object 1 tilde object 2, which in turn is going to call the is equal feature, right, in the corresponding class if it was redefined. Okay. Any question? Go ahead. You guys decide the order. Yes, go ahead.
Equals and expanded also called?
Yes, it will in turn. So what I'm trying to say is, when you say equal sign over here, in the case of, when you say equal sign, and A is actually expanded, it's as if you try to say tilde, and tilde in turns is going to call the is equal feature that's in A.
But does any object that is expanded, do you have to do the is equal feature?
Do you have to redefine? You don't really have to. Yeah. So of course, if you didn't really redefine it, it's going to do just default operation. If you did define it, then you will call that redefined version. It depends. Yes. Yeah. Okay. So now let's come back here, and then so that means this guy here, EB1 equals EB2, is going to compare their contents. In that case, this guy here will just be true, because EB1.I is equal to 0. And also EB2.I is also equal to 0. They are the same. Just compare their contents. Right? Just let me mention something quickly. In a more general context, here I try to make B very simple structure, just a primitive attributes. When you actually got more complicated object structure that's expanded, what you will do is it's going to call the is equal feature, which might presumably recursively compare the structure of the object and compare their values. Okay? Question?
So then if we had an attribute
Mm-hmm.
that was of a reference type, so then it had a linked list,
Mm-hmm.
and you're comparing two linked lists, then would it compare based off the runtime?
Yes. So the question was, let me just a little bit diversion here. The question was, let's say in the class B, remain to be expanded. If I add another, for example, let's say linked list, I'll say list over here, that would be linked list of maybe string. Now, when I say equals over here, what's going to happen? The answer is it depends. Depends on how you redefine the is equal feature in B. Okay? It could be that I can say for class B over here, I can say inherits any, and then I can say redefine. Okay, let me make it a bit thinner. Redefine is equal. Right? You know about that class from the what's the edge class or the vertex class back in your lab 1. Okay, if you do that, so now in the is equal feature, okay, you have some argument over here, and now it really depends on how you redefine this, right? If you simply say result is simply assigned to I equals, for example, other.I, and also list equals other.list. That can be one version, in which case you're saying that these two expanded objects when at the runtime, how should I execute this particular equal sign over here? It depends on the is equal feature. In this case, it's going to compare the value of the primitive value I, and it's going to compare the equals, going to compare the address of the reference type, right? It depends. How can I make it so that it's going to compare the contents of the linked list? Any suggestion? By modifying the is equal. This would do it. Right, so now, in the pink version over there, if I simply say tilde, so what that would do is it's going to compare the two linked lists by the is equal feature in the linked list, which is going to call the is equal, hopefully. Okay? All right. Okay, that's just an aside. Okay, but for now, for the rest of the discussion, we still assume this particular addition is not there. Okay, just make things simple. Okay, we still just got I. So now let's say this. If we say EB2.change I 15, what we're doing is simply modify this particular object to be 15. Okay, good. So now EB1.I will be 15, correct? EB2.I will be 15. Is that correct?
So you accidentally change EB1
EB1 and, oh, I beg your pardon. Sorry for the confusion, I realized. So now when I say EB2, sorry about that, I just look, I thought that's EB1. EB2.change I is going to be changed to 15. And now you will agree this is fine, right? 0 and 15. Okay, that should be okay, right? And now if I do the following assertion, how about this? Check EB1 not equal to EB2. Would that be true? True, not because they are different objects, but because their contents are different. Okay, let me write it down. So now the reason that this will be true is simply because EB1.I is not the same as EB2.I, 0 versus 15. Okay. Now the interesting bit here. If I try to do EB1 is assigned to EB2, what we said in the previous case, if you did it for reference type, you're basically copying address over. So you got to change the arrows, right? But now we talk about expended. Now, when you say assign over here, it's really like calling a copy constructor that you did in 2030. You simply say, I want to recreate EB1, basically. However, the way I recreate EB1 is by copying over everything that's in EB2 over, just the contents. Okay. So what I will do is, so now EB1 will be copied over by all the contents of EB2. 15 is copied over here. That's it. Yes? You mean if EB1 was not expanded? Yes, exactly. So now that's exactly the case we talked about before, right? Remember in the previous case over here, when we say EB1 is assigned to EB2, Right? In that case, you're basically saying EB1 is not going to store the address of this particular object anymore. Instead, it's going to store the address of this particular object that's pointed by EB2.
No, but if EB1 was not expanded and EB2 was expanded.
It's not possible. Okay, you cannot. Yeah, the question was like this. Okay, good question. It's still worth clarifying. What if you got something like this? Let's say you got EB1. Let me just make it a little bit more general. If you got expanded, let me just class, and then let's say B, okay? Notice that B is actually a reference type, right? Let's say object number 1 and also object number 2. Object number 1 is simply reference, and object number 2 is expanded. If you say obj1 is assigned to obj2, that's more or less what your question was, right? I believe it's going to be not compiling because you're mixing the two concepts over here. We simply don't know whether you should really copy the reference or the contents. Okay.
So in this case, if we're to do the same thing of something that's expanded and something that's not, if we're just trying to compare it, equal or a tilde, would it also not compile?
I believe so. So if you say obj1 equals obj2, for example, you just cannot compare because you don't know whether you should compare address or content. I will try this example here, maybe make some small demo, maybe next time. Yeah, I'll try to, yes, if you're interested. Okay, any other question about this? Just a brief mention. So I think in general, it's also a good idea. You don't try to mix the two together. You also get confused by yourself. Yes? What do you mean? Sorry.
Like redefine the class.
How do you redefine the class? What do you mean?
No, I mean redefine the equal.
How do you redefine the is equal feature? Is that what you meant? Yes. That one you have done that already in lab 1, I believe, right? So just mention quickly. So the way to do it is by
I mean redefine compare with the reference class and expanded.
the idea would be you don't want to really compare expanded objects and also non-expanded objects. You don't want to compare two things. They are actually conceptually different. That's the idea, right? So usually you want to either compare two reference objects or you compare two expanded objects. You don't want to mix. The semantics is simply not clear what you do. You mean, you know what, let me try this out, maybe myself. I didn't try it out because it's simply confusing to do so. Even if the compiler wouldn't complain, you better know what you're doing, okay? Okay, let me try it out and then maybe I'll come back to you, okay? Okay, let's go on to finish the rest, okay? So now over here, EB1 and EB2, they're simply expanded. So now the semantics of copying is very clear. So we simply copy the content. So now 15 to 15. Now if I say check, okay, I say EB1 will be 15 and EB2 will be 15. Agree? Good. So because they're both the same. So now again, the reason that this should pass is because the contents are the same, but they're still different objects, just different objects, right? And now if I say EB1.change I, this is where the aliasing occurs in the reference case, but now there's no aliasing. So that means if I say EB1.change 10, so now I change that to 10. It doesn't really affect EB2. So now if I say EB1 equals 10, EB2 equals 15, that's okay. Right? On the other hand, remember the previous case, this guy here, he actually fell, right? Just to remind you. Okay. Okay, finally, if I check to see EB1 not equal to EB2, are their contents the same? They are not the same because 10 versus 15. So this guy here not equal to, that should give you true. Okay. Yeah, try to review these two comparisons quickly once you study. So it will illustrate how the expanded type actually work at the runtime. Any questions? Yes. Yes. Good question. The question was, Let me try this out and prepare some demo for everybody before I set it for sure, okay? Yeah, let me prepare some demo maybe after reading week. I will talk about it in the first class. The question was basically about, I'll put it down just in case I forget. Let's say you got class, let's say A over here, expended. Okay, and then you got, let's say, I, integer, that's primitive, that's expended, okay? Let's say you got string, which is reference. Let's say that's more or less the class, right? And now if you say expended A, 1, A. Expended A, 2, and then A, okay? Let's say after some setup for the values for the two objects. So now if I say EA1 is assigned to EA2, okay? What would be the consequence of doing this? Specifically, for this particular string, are we going to copy its reference or the entirety of the string? That's the question. Okay? I will try to do a little bit demo, maybe after the reading week. I will show you in iPhone Studio how to find out. Okay? And feel free to try to find it out yourself by just using iPhone New and create a small project. That's what you should do when you study a new language. Okay? All right, any question about expanded? Any more? Okay. Go ahead. No, you can simply declare EA1 to be of type A, EA2 to be of type A. I believe it will be some error. If you say expanded and expanded, right? So if A is already expanded, you say expanded again. You wouldn't just make it more expanded, or you wouldn't like a double negation make a reference, neither. So I think it would just be an error. Okay, you shouldn't do it. Yes?
This is a discussion between a non-expanded and expanded object, but if you were to actually just compare the context of it, it would be fine, right?
What do you mean compare the context?
If you were to use the tilde instead of equals.
If you talk about tilde, actually you do have a slice in the summary, so you'll find your answer. Yeah, okay. Okay, so now if you know, yes, go ahead. Oh, you mean to explain it again, how it compares? Yes, exactly. So now, whenever you got expanded class, okay, let me just make it clear here. Yeah. If you got expanded class, again, let's say expanded class C, and then you got some definition over here, okay? And then let's say you also say I'm going to redefine is equal. And then, of course, you got some implementation over here. Of course, it's completely up to you. That's the supplier side. At the client side, if you say expanded C1 of type C, expanded C2, and then of type C, okay? You do a little bit of modification of both objects. Now, if you say EC1 equals EC2, and implicitly, what it will be translated into at the runtime would be, you say EC1 tilde EC2, which will in turn actually call this particular is equal. So it really depends on how you redefine the is equal. Okay. Yes, so if you find that you actually need to have such comparison in your code, you want to make sure the corresponding is equal is redefined properly. That's the point, yeah. Yes? What would be the, it's more asking about what's the advantage of composition, back in 2030. So back in 2030, the way I would phrase about what would be the advantage for composition is there are certain objects you simply don't want to share them between objects. For example, keyboard, for each workstation. You don't want to have any aliasing issue happening there at the runtime. So now in Java, what you have to do is you have to implement a copy constructor yourself appropriately, manually. On the other hand, in IFO, if you believe for this particular kind of objects, you don't want to share that at all. You simply use expanded keyword. In that case, at the runtime, as I explained, you will just make sure there's no aliasing happening. Yeah. So, okay, let me, your quick answer. Why would expanded class be useful? It's the same question as why would composition be useful? Because we don't want sharing for certain objects for your application. Yes?
Say if you don't expand it, say EC1
Yeah, but if you simply just do deep twin, of course, deep twin can also disallow aliasing, but you got to do it by yourself, right? You got to manually say something dot deep twin, and you want to make sure you do it at an appropriate time. Otherwise, you're wasting the resources. But if you do it just by adding expanded keyword, the compiler is going to optimize the generated C code for you, so you don't have to worry about the performance. Yeah, good. Okay, good. Let's now go on to question about expanded type, and then we can go on to the, oh, I promise I'm gonna have a summary slide for you. I believe it is there. Okay, so now expanded versus reference, right? We talked about it already. What I want to show you is, if for reference type, so if you say x is assigned to y, you just copy address, okay? If you say x equals y, compare references. On the other hand, for expanded type, if you say, oh, when you have expanded type, there's no notion about address. Again, let me emphasize. And then when you say x is assigned to y, you just simply copy the contents. You don't copy address. Now, if you say x equals y, that's as if you say tell that, right? As I keep saying. Okay, that's a summary slide for you. All right. A question for you. Let's say we have the following problem, okay? Every published book has an author, let's say a single author book, right? Maybe you have multiple authors, but it doesn't matter. Let's say for simplicity. Every published book has an author. Every author may publish more than one book, right? Should the author field of a book be reference type or expanded type? I can tell you it's an open-ended problem, which means either you say reference type or you say expanded type. Either answer is acceptable as long as you can justify for your particular need. But I would like to hear justification. Anybody? Jordan.
It should be a reference type.
Why should that be a reference type?
Because if certain things change about the author, you want those changes to be reflected.
To be reflected right away because of aliasing. So what Jordan is saying is he made a very good justification for the case of reference type. Let's say we are talking about maybe some online record for the author, right? The online author page is actually referenced by many other book pages. And whenever you change the author's page, it should be reflected to all the other books page. That's a reference type. However, how about this? Let's say I have a physical book, let's say, and then if I simply modify the author field on the cover, is it going to affect another physical copy? No. So that's another scenario where reference type may not be the case. You see what I mean? Okay. So this is simply just to show you that. Let me just show you here. We basically got two options over here. Either you want to justify for your case, you want every book to add every book with the same author to share the same author objects, maybe like a web page. In that case, you should be referenced. On the other hand, if you just simply want to model the scenario for physical copies, modifying one physical copy wouldn't modify another one, right? So now in this case, it would be just like that. If I simply model this particular book's author here, it wouldn't affect the other one. Okay, so just two scenarios for you. Okay, in case you're not very comfortable, let's see this. In the case of reference type, if I simply modify the author's last name, for example, to Alan, it will be reflected right away to both books. That's reference type, right? So now, if I have physical copies of the book, in that case, I've modified this particular copy to be Alan, for example. It wouldn't affect all the others. Which one should you choose? It depends. That's why it's an open-ended problem. Okay. Any question about modeling using expanded? The key concept is about sharing. Yes?
You said on the test, you initialize the test, you get it after you initialize expanded type.
Okay, let me just go there first so everybody can follow that. You're basically talking about, yeah, I declare EB1 and EB2 of B, and B is expanded, yes. And then I can simply use them right away, yes.
Yeah, so what will be the contents?
Oh, by default, what will be the contents? Good question. The contents will be whatever that's in the default creates. When you declare a class to be expanded, if you have a class, let's say B, let's say expanded class, you got two cases. I'll mention both. if you got expanded class and then B, okay? Let's say in this case, you don't need to have, oh, by the way, for expanded class, you don't need to have constructor because you can just let every attribute to be initialized to their default values, okay? So now, in this case, if I got I simply of type integer, okay, that's case number 1. In that case, if I simply declare, let's say, EB1 of type B, so what that would do is simply initialize all attributes to their default values. In that case, for integer, it will just be 0. For Boolean, it will be false, and etc. Okay. On the other hand, you can do the following. I got another version of expanded class B. And now I can have a default constructor. Okay, I'll show you how to do it. You would say inherits the class any, and then you would say redefine. It's something called default create. It has to be spelled exactly this. Okay? Default creates end. And then, so now, in this case, I can say default creates, okay, assuming that I already got I, okay? I just don't have space. And then I can say for do, I will say I is simply initialized to be some default value, let's say 5, for example, right? If I say 5 over here, so this is the second version. In the second version, I have some customized version for the default value. Oh, that's not very good. Can I just make it a little bit up? Good. So now let's say for the client side, if I got EB2 of type B, now in this case, implicitly, I for compiler will actually tell the runtime to actually do the following. It will say creates EB2 dot default creates, which is going to initialize to be 5 implicitly. You don't need to do it explicitly by yourself.
Are we going to do another example with just the specific object being expanded?
Specific object to be.
Because you said that like EB1 itself can be expanded without the entire class needing to be, right?
Yes, correct. We wouldn't see further examples, but that'll be it. But are you interested in a particular example?
Yeah, because I'll talk to you after.
Okay, talk to me after. And then if that's a good example, we'll share with everybody. Okay, talk to me afterwards. Good. Okay, so that's about it for expanded. So now we're going to talk about another issue. Okay, let's now talk about singleton pattern. As I said, every time when we talk about a particular pattern, we really want to know what the motivating problem is. So later on, if you see a similar problem, you would know I should really use a singleton pattern. Okay. So now we consider 2 different problems, but they are really of the same nature. Let's say bank accounts, first of all. Let's say every bank account, it could be maybe bank account for withdrawal, the bank account for deposit, or bank account for international transfer, right? So they actually share interest rate, exchange rate, minimum balance, and maximum balance, let's say, a simplified version, okay? That's one problem. All the bank accounts should share some bank data, which means whenever you update the bank data, all the existing bank account objects should know about it right away, okay? And the second one, for those of you who took maybe operating system course, so that's more like you want to have some shared data as well, like a semaphore, for example, right? For those of you who took the course, you will know what I'm talking about. But let's say in the prison lab, all the printers are shared among all the workstation in the prison lab. So that's also like a shared resources. So it's quite a common problem to solve, to really make sure you got some shared resources, but how can you make sure any update to the shared resources will be reflected back to all the objects that depend on the shared data, right? So that's the problem. Let me give you some initial solution, and we have to criticize on that, whether the solution is good or bad. Okay? I'll give you a little bit hints in just a moment, but let's take a look. I'm going to just talk about the bank account case, right? It's, for the processes, you can try to relate in a similar way. Let's say we have a class called deposit, and deposit is simply going to inherit from shared data. So now, one possible solution to say, I have a common parents that's going to define all the shared data and let all the child classes to inherit from the shared data class, right? That's a intuitive solution. Let's see. We got deposit, we got withdraw. Oh, by the way, for deposit, what's really relevant to it should be just the maximum balance. What should be the maximum balance I can deposit into the bank? Maybe it should be no more than 1 million, for example. Okay? Similarly, for withdrawal, I want to make sure the resulting account should be maybe at least $1,000 in the account. You cannot go below that balance. Okay? So it seems like every account class of different kind, they have certain data that's relevant to them. But we somehow just take the union of them and then put in the parent class. We got international transfer, in which case exchange rate will be very important. And also we got another class called account, right? We just got 4 different kinds. We got 1, 2, 3, and 4. And for the account, we just got, just different data structure here. But focus on deposit, withdrawal, and international transfer. Okay, focus on these 3. And then for the shared data class, we have interest rate, we got exchange rate, we got minimum balance, we got maximum balance, and maybe more. Okay, that's kind of the structure we have. And do you see any problems over here? Again, at the runtime, this particular implementation might just work. You can just make it work programmatically. But now we talk about design. And whenever you want to think about design, whether it's good or bad, you have to really think about what if I make some changes to the existing objects or data? What will be the consequence of doing that change? Okay. And I'll give you 2 hints that you can think about. Every time you want to judge whether the design that you come up with is actually good, you can use design principles to think about whether the design you have at the moment satisfies certain design principle. Now I'll give you 2. One is called cohesion. The other one is called single choice principle. Right? Well, you heard about single choice principle already, right? Does anybody know what a cohesion is? Anybody? Cohesion. If you don't know, that's fine. I just want to know if anybody knows. Okay. Cohesion simply means consistency. I'll put it down. Cohesion simply means features in a single class should serve the same purpose, to put it in a simple way. And for those of you who actually took 2031, do you know what the #1 principle is for the Unix system, for commands? You see, in the Unix system, you got so many commands, right? Maybe one command will do what's the current directory, and one command will do what's the contents of the current directory, and etc. There's a principle underlying the Unix design. Exactly. Do one thing and do it well. Okay, just to relate this to you. Which means your class should be, all the features in your single class should be only doing one thing and do it well. It shouldn't be a so-called Superman class where you put everything together. And for your lab #3, you want to avoid Superman class. You really want to think about what would be the best way to decompose your problem into smaller problems. Okay? Anyway, we'll talk about it later. Okay, let me just mention that it's called the Unix principle. Do one thing and do it well. And do it well. Okay, so these are the 2 hints to you that you can judge whether the design is ideal or not. Any idea? So now you know what the 2 terms really mean. And single choice principle simply means whenever you make a change, you better change it only a single place. You shouldn't be multiple places, which means your data shouldn't be redundantly stored in some way. Okay? Any idea? I can give you further hints, but I just want to see if anybody have any thoughts before I give you some hints. Yes, go ahead.
I think for the shared data, say different accounts.
Yeah.
And the interest rate you want to do the same, but then you can change the interest rate for the account versus another account, even though you want it to be the same.
Ah, that's good. So what you just talked about is basically single choice principle. I'll get to the diagram in just a moment. I just sketched that very quickly. Imagine that at a runtime, if I got different objects over here, and all of them got an attribute called interest rate, IR, and all of them got interest rate, all of them got interest rate. Let's say if I decide Now I want to change let's say currently it's simply 2.3. Okay, I just made it up, 2.3. Currently it is consistent. If I decide to change the interest rate from 2.3 into 2.15, for example, is there only a single place I need to modify? Are you sure? Multiple places, right? I need to modify this object here to be 2.15, this object here to be 2.15, this object here to be 2.15. Multiple places. So it violates single choice principle. Somehow the interest rate is not really shared. It's actually multiple copies of the interest rate value. So whenever you want to modify the value for the interest rate, you have to go ahead to all the existing objects that use interest rate and modify them one after another. So that's multiple places. So that's a violation of single choice principle. That's good. What about cohesion? Does this particular design over here using inheritance violates cohesion? I'll give you a little bit hints. Let's talk about the deposit clause, right? As I said in the comments over there, as far as the deposit is concerned, only maximum balance is important, right? But at the runtime, does a deposit object store anything other than maximum balance according to the current design? I heard no. Anybody would say yes? Well, that's really back to how you understand how the inheritance work at the runtime. Okay, let me tell you briefly, and then I have diagram to help you. Every class, like a deposit, withdraw, and international transfer, each one of them inherits from shared data, which means all the attributes over here will be part of the object states for that particular class, right? So that means in the case of deposit, not only that I got maximum balance, I also got minimum balance, exchange rate, and interest rate. I got everything here. Okay? So somehow in the deposit object, I'm forced to actually store some data that's not relevant to my purpose. It's a very quick verbal remark. Okay? Let's see a little bit more visual. Okay? Let's see the following. I already discussed all the two design principles. Now I'm just going to make it a little bit more confirming. Okay? Let's talk about the following scenario. Again, we got shared data. That's a common ancestor, the common parent class for all the classes we're talking about. Okay? We got interest rate, exchange rate, minimum balance, and maximum balance, let's say. Let's say from the client side, we have to declare deposit, declare withdrawal, and declare international transfer. Okay? Let's say for deposit, D1 and D2. So D1 may be pointing to this object here, and D2 pointing to this object here, deposit type, right? And what will be the structure for that particular object? It should be all the attributes that's defined in the shared data, including interest rate, exchange rate, minimum, and maximum, right? And notice that the only thing that's relevant to deposit is just the maximum. All the other three, they are not relevant. You can immediately tell it violates the cohesion principle because you are storing more than necessary for the deposit objects. Okay. Similarly, let me just finish the picture, and then we talk about single choice principle. So now, let's say for the withdrawal, I got maybe W1 pointing to here and W2 pointing to here. Similar principle. The only attribute that will be relevant to withdrawal will just be minimum balance. All the other three, they are not relevant, and we're storing them. Cohesion violated. Okay. Finally, let's say we got international transfer, right? T1 pointing to here and T2 pointing to here. The only thing that's relevant would be exchange rate. Okay? All the other three, they are not relevant. Okay, any question about cohesion? Cohesion is violated, right? Apparently, right? Because you can see the structure for every object here is the same because they inherit from the same parents. What about single choice principle? Let's say we decide for now that the interest rate, for example, is going to go from 0.11 down to 0.09. Now, how many places do I need to modify? In this case, 6 places, right? I need to modify here, modify here, modify here, 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 and here. All change them to 0.09, for example, in multiple places. It's not a single place I should change, right? So these are important insight into the sharing data problem. Okay? Any questions? Yes, Rain first.
I'm wondering about changing the rate. Can't you change it from the shared data class?
Oh, over here at the runtime, okay. Let me, okay, the question was, can we simply change the data in the maybe a shared data class? It wouldn't work because normally speaking, for the shared data, in this case, you would have just make it maybe deferred. For example, to make sure you don't really create instances directly out of the shared data. You only want to create instances out of deposit, withdrawal, and international transfer. But doesn't really matter because when we actually declare attributes over here, this is only the class level, which means every object of this particular kind, they're going to have all these 4 attributes in their objects, local copy. Right? You can see for this particular deposit objects, we got local copies for example, maximum balance. And for another deposit object, we got another local copy for maximum. So they're just different copies. So it wouldn't work if you just change one local copy. We'll put it this way. There is no aliasing.
Would it be possible to include some kind of macro?
Implement macro. What do you mean macro?
So like, you know, having C, we can have macros on the top of the class so all of his children can use.
Actually, macro wouldn't solve your problem. In some way, inheritance is really like a macro. In the parent class, we define what should be common among the children, and then we simply put it there. But the problem is, you can see for every child object over here, the blue, the green, and also the pink, each one of them has the same structure, which means we got 6 different local copies of the same attributes. That's where the problem is. Okay? So what would be an ideal solution? Ideally, we would like to have the following 2 criteria satisfied. Number 1, we want to make sure the class stores only what's necessary for that particular class. Number 2, whenever we want to change a particular part of the data, it will be reflected right away to all the existing objects that rely on that, only a single place. That's the criteria for the ideal solution. Jordan.
Does Maple support inner objects like Java does?
We don't have inner objects, I'm afraid, in iPhone.
Okay,
Yeah.
then you wouldn't have to worry.
Well, actually, you got something. Oh, how about this? In Java, you got another way to. Well, how about this? In Java, how do you make sure something that can be shared among all the objects of a particular class? Static. I agree with you. Yes, static. We need something similar to static to solve the problem. But I argue that when you use static in Java, you definitely can make this work, actually. But again, it's not a good design. But I will try to justify why.
You might want to have multiple accounts, though.
Yeah, we'll see. We'll get it. Yes. Okay. Anyway, so let me go over a little bit slides, and then I'll sketch some solution for you. Okay. Let me go back here. Okay, about cohesion. Okay, that's something I just explained. You can just read the slides. So now this is what we want to have. We want to have 2 separate notions. One notion is about data itself, interest rate, exchange rate, etc. Right? Just the shared data. Another notion is about the sharing of the data. We want these 2 things to be decoupled. It's like a separation of concern. Okay? That's the criteria number 1. We're going to see in the solution. Number 2, of course, we want to make sure there's only a single instance of the data. That's something we want to make sure. Whenever you create more than 1 instances of the same of the shared data, it's not singleton. Okay. So now, what I would like to do is I would like to give you a little bit idea about how you can do this in iPhone. Well, basically, how you can do static in iPhone first of all, and then I'll argue that just with the notion of static is not going to make it enough a good design. That's something I will argue. Okay, we'll get there. The way I'm going to do it is tell you this keyword you have to learn called once. Okay, let's see how we can understand it. Again, I'm going to use an example to show you. Notice one thing. Typically, let me just look at this class over here. Okay, let me make it a little bit bigger. Let's say I have a class called A, and then I simply just have some empty constructor. Okay, and then I have 2 routines that's going to return something. Both of them will return array of string, both of them. Okay. In one case, I'll simply say new array, and then give a string. And if here we'll start with the do. That's something you have been used to, right? That's something you will have to do as well in the lab test. The way I do it is very easy. I simply, first of all, create a result to be an empty array. And then whatever the string it is, I'm going to add it to the end of the array. Okay, easy. And it seems like for the once version, I'll explain what once really means in just a moment. Okay, for the once version, the implementation here is exactly the same as over here. The implementation write exactly the same line. So the only difference is the once keyword over here. So we want to know what's the consequence of using once rather than do. Right? That's our concern here. Okay, everybody clear about what we're going to illustrate? Okay. So now, what I would like to do is to trace the code a little bit together with you. Okay. Now that we know what the issue is, let me just clear this. Okay. Let me just make it a little bit cleaner. Okay. So for the first case, I trace the first one. Okay. For the first case, I'm going to test the over here. Let me just highlight it. I'm going to call it a new array. Okay. So this version. For case number 1. Okay, let's not worry about the ones just yet. Let's understand without the ones how it's going to work. So now, if I have array 1, array 2, if I say array 1 over here, okay, it is going to return an array simply containing Alan. Agree? It's just forcing Alan to the end of the array. Okay, so that means ARR1 is pointing to an array of just one single element, index 1. And then it's going to point to Alan. Okay, everybody agree? Okay. Now, of course, array 1 will just be count will be 1, and the first element will just be Alan. Okay, that's easy. Question for you. If I try to say array 2 is assigned to a.new array, I'm calling the same query over here, the same, but with a different argument mark. What should I get? Number 1, should I get a different array? Should I? I should, because calling that each time will just create a new array to begin with, first of all. Right? So what I would get is ARR2 is now going to point to another array of size 1 as well. But now this time it's going to be Mark. Okay, at the end, I'm going to say ARR1 equals ARR2 should be false, because they are different array objects. So this part should be false. Negated will be true, so I will pass the test case. Okay, this illustration should be no surprising to you, right? Okay, that's something how you have understood the reference type. Let's see in the next one. We're going to try to trace the once array routine. Okay, so now I'm going to call new once array, and I'm now going to focus on this particular one, where I say once as opposed to do. Okay, let's see what's going to happen. Whenever you're trying to call a feature or query with the once keyword, here's the principle. What really matters is the very first call to that query. In this case, it will be this one here. So this is the very first call. Every other call that's later, I'll just call a subsequent call. Okay, so this is one of the subsequent call. Okay, and then over here, when I call it the first time, it will simply just execute these 2 lines faithfully. So for the very first call, the behavior will just be like as if you didn't have the once for the first time. Okay. So now what this will do is array number 1, ARR1, is now going to point to basically, should be just an array. Array index 1, and then it's simply pointing to just Alan. Okay. And now, immediately after the first call, imagine that there is some implicit reference maintained by either runtime for you, implicitly. There's simply some reference telling you this is the object that's returned by the very first call for the once routine. Now, every subsequent call for this particular routine, what you will return is just the same objects. Effectively, you ignore what's in the implementation. Let's give a try. So now, when I say over here, array number 2 is going to be the second call, return value from new once array, right? In that case, I give Mark. in some way mark here doesn't really matter because it will just be ignored. So typically when you have a once routine, you don't really have parameters usually. Okay? So now mark over here will just be ignored because when I say over here ARR2, what should be its value? It will just be whatever this particular reference is pointing to. So it's pointing to the same array. Okay? Let me finish this and then I'll take your question. So now if you check here, ARR1 equals ARR2, it will just be true. Okay? Which means when you are trying to call the once routine for as many times as you like, you always get back the same reference objects, always the same. So this will help us to get shared data problem resolved, partially, only partially, not totally. Okay? Okay, any question about once? For the once, yes, for the once routine, you only execute body of the implementation once. After the very first call, you somehow cache the result somewhere. For any subsequent call to the same once routine, you simply return whatever the cache result. So that's why ARR2 is simply just return whatever the cache reference, which is the green one, right? Okay, let me just say briefly and I'll take more questions. For the very first time, I simply created, when we call this once routine the first time, we simply create this object for the first time. And then implicitly, it is cached into ref. Now, for the subsequent call over here, we don't worry about the implementation over here. Oh, sorry, not here. We don't worry about the implementation here anymore. We simply return this particular reference. That is why ARR2 should just point to the same object over here. Any questions about this? Yes. Actually, for the once routine, I would say not necessarily you just use it for the constructor. You can use it for some query. You can use it for some commands. Basically, if you declare some feature to be once, you're saying that only the very first time of computation is important. All the subsequent use of that will just return the same value. That's basically what the once routine is doing. Yes? It's not like final. Final simply means you cannot modify the implementation, right? You cannot really you cannot change its value. I would say once, in a way, it's a little bit similar to static in some way, partially. Okay? Okay. Let me just go a little bit further, and then I have to stop a little bit earlier today, but we'll continue for sure. I think before the reading, before you come back next week, we have to definitely finish the Singleton pattern. But I would suggest you should really study all the way up to slide number 38. So guys, bear with me, please. Bear with me. So now, up to slide number 38 is about how the once routine really means in iPhone. That's something you will need in order to understand Lab 3 as well, because we do use once routine in the ETF. Okay? So up to here, that's something I will assume you will actually study up to before we come back next, not next Monday, but the Monday after. Then we will do it. Okay? Okay, so now let me stop the recording over here.